Hello, let's continue our Sudoku adventure with An Adventure to Kill For by Randall. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. These are these cells surrounded by dotted lines, like up here, like here. There's also a clue on the top left. The clue is the sum of the two digits. So these two digits, for example, sum to 9. So we could do, for example, 4 or 5, or 3, 6, or 6, 3. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. I think a good way to get started here is this box 1, looking at what we call the outies of the sum. Now, the first thing to understand is that every row, every column, and every box in a 6x6, the digits will sum to 21. Because we have 1 to 6 exactly once each. If you add 1 through 6 together, it's a triangle number, you get 21. So, we know what these 4 cells add up to. They add up to 9 plus 8, which is 17. So how do you get from 17 to 21? Well, you have to add 4. So these 2 cells need to add to 4. And if 2 cells, which can't repeat, which these can't, sum to 4, there's only one option, 1 plus 3. Okay, so now if we think about this 9 cage, it needs to sum to 9. There's only 2 ways to do that, 3, 6, or 4, 5. But the 1, 3 pair has removed the 3, 6 as an option. So this has to be 4, 5, which then makes this the remaining digits 2, 6, which does add to 8. So we did the math right. I think maybe this column is helpful now. Okay, so actually the first thing I'm seeing is that we need a 6 in the column. You can't put a 6 in a 6 cage or a 5 cage. 6 would need to be 6 plus 0, 5 would need to be 6 plus -1, neither of which is possible. And so the 6 ends up here. I suppose that puts a 6 down here somewhere, but maybe I didn't need to mark that. This adds to 5. It's either going to be 1, 4 or 2, 3. Okay, that does make what's called a virtual 1, 3 pair here. What do I mean by that? Well, we can't exclude both 1 and 3 from this 5 cage. It would make it add to 6. Or if you think about it another way, we're going to be 1, 4 or 2, 3. So there's no way to avoid either the 1 or the 3. And this cell is also a 1 or a 3. So one of these cells will be the pair that goes with the 1, 3, the other 1, 3. So this cell can't be 1 or 3. It already couldn't have been 3 because it can't do 3 plus 3. But it can't be 1 now. So let's just think about 6 in general. 1, 5 is an option, but it would have to go this way for the reasons we stated, the 1, 3 pair. 2, 4 is the other option. I think it could go either way. Okay. Let's take a step back. All right, I have this 9 cage here. This 9 cage here can't be 4, 5 because we can't have 3, 4, 5s in this row. So it has to be 3, 6. But this 2, 6 pair here tells us the order. That's 3, that's 6. That gives us the 1 and the 3 here. This now has to be a 2, 3 pair. So this can't be 2, which means that's not 4. We're left with this 4, 5 pair. Okay, that's not a 6. This is a pair. This is 4, 5. 4 can't go in an 8 cage, so that's 5, that's 4. Because if a 4 went in here, we need another 4 to add to 8. That's no good. So that's a 3 to add to 5. That gives us the 2 and the 3 here. All right, good progress so far. This is a 1, 2 pair. Oops, not like that. The 3 doesn't really help our 6 at all. But we could fill it out. It's either 1, 5. This 5 tells us it would go this way, or 2, 4. This 4 tells us it would go this way. This 5 cage is either 1, 4 or 2, 3. You can't have a 3 in it because look at these 3s. So this is a 1, 4. So the 1, 4 that doesn't end up in the 6. Wait. 1 plus 5, 2. Oh yeah, the 1, 4 doesn't distinguish the 6 cage. But the digit that isn't 1, 4, sorry, the 1, 4 that doesn't end up in the 6 cage. What am I trying to say? There's a 1 and 4 go down here. They can't both go in the 6 cage because that adds to 5, not 6. So the other 1, 4 ends up here. That's what I'm trying to say. I was also trying to say that it doesn't actually resolve the 6 cage. Because we don't know. We could have a 1, 4 or a 4 in it with the other digit. Is it the 7 cage that's helpful now? Well, it's not 3, 4 because it sees a 3. So it could be 1, 1, 6, which would go this way. Or it could be 2, 5. This can't be 2, so that would be 5, 2. And that's it. So that makes a 1-2 pair in this box. So this is a 4, that's a 5. 5 has to go with 1. So this is 2, 5. That's 6, 2. That's 4, 5. This is 2 plus 4. That's 1 plus 4. This 5 ends up here. This is 1 and 2. Cool. This box finishes with a 3. So this is 2, 3, 6. This has to be the 6 because it can't be 2, 3. This can't be 2, so it's 3. This 4 goes here because of this 4 here. This is actually just finished. It's a 1. That puts the 1 there. This is a 6, and so we need a 5 and a 6 up here. That's 6, that's 5, and we're done. Nice. Cool puzzle, Randall. I liked that idea. I liked the interaction between the cages we had. We had this sort of virtual 1-3 pair that was fun. Placing the 6 in this column, that seemed good. The 9 cages interacting. The 5 and the 6 cage interacting was also interesting. So cool. Nice puzzle. Hope you enjoyed it as well. And if you did, then why not leave a like, subscribe, and a kind comment below.